Hello class, this is our part 2 of our lecture in our module 7 that involves a problem solving related to a spectroscopy. Now let's cut to the chase and let's move on to the slide number 22, which involves our sample problem number 1. Okay, so dito sa problem na to, kung mapapansin is you can see here a form of electromagnetic radiation with a wavelength of 455 nanometer. Calculate the frequency of the radiation and the energy possessed by one photon of radiation. So may sagot na tayo. Pero paano ba natin solve yung mga yan? So we have a formula of C is equals to lambda V na na-discuss throughout the discussion, where the lambda is the wavelength in meters. The C is a constant speed of light or the velocity of light, and the C and the V is the frequency. So, i-arrange lang natin yung equation and turn it into C over lambda. Ayan, ibababa mo siya. So, since yung C is always constant, na 2.998 times 10 raised to 8 meter per second, slash yun na, all over the lambda, which is 455 nanometer. Pero i-convert natin siya into meter. So, let's pa natin. So, sa per natin, per 1 nanometer, meron tayong 1 times 10 raised to negative 9 meter. So, ayan, solving lang natin, input natin sa ating calculator. Ayan, and you will get the value na, ayan, 6.589 times 10 raised to 14 S negative 1 kasi nasa baba yung ating yung second natin, meter per second. So, write natin na 6.589 times 10 raised to 14 hertz kasi the reciprocal of second is also a hertz natin. Now, how do we calculate for letter E? For E, the energy of the radiation. So, yung formula na discuss sa ating slide natin. Saan ba yung tinutukoy ko dito, guys? Ito, ayan. E is equals to HV. Okay, E is equals to HV. Okay, so since meron na tayong V or the frequency and H is always constant, meron siyang value na ayan, no? Ayan, makikita naman dito. Ayan, 6.626 yan actually, pero sige, sundin natin nasa PowerPoint. Na 6.624 times 10 raised to negative 34 joules second times the frequency na HV value, substitute lang natin, 6.589 times 10 raised to 14 per second or S negative 1 or hertz. So, ma-cancel yung S, yung second natin, and we will yield a value of, input ko lang din sa calculator ko para mas ko natin, times 6.589 is 10 raised to 14 and 4.364. Actually, dapat ito ay 6 eh. 6 dapat yan, guys. So, i-ano na lang din. That is 6 actually. Ayan. So, ang sagot natin is 4.365. Pag ni-round out mo is 4.37 naman siya times 10 raised to negative 19 joule. So, that's for our sample problem number 1. Okay? So, take screenshot, guys, so we can proceed in our next problem. Okay. For our next problem, okay, saan natin? Saan ba yung next problem natin? Wait lang, guys. Not responding. Ayun. Okay. Our next problem is all about the Beer's law. Okay. For our sample problem number 2. Wait, anong nangyari? So, may sagot naman na tayo. Shucks. Ayan. So, ayan. Calculate the concentration of solution of a species which has an absorbance of 0.494 at 525 nanometer. If the cell pant length is 1 centimeter and the molar absorptivity is 1.38 times 10 raised to 4, that's actually liter per mole centimeter. Liter per mole centimeter. Sir, paano po natin i-solve to? Okay, sa may Beer's law, guys, given naman siya sa may formula sa may slides na ito. Ayan. It's just A equals EBC or molar absorptivity. So let's write the formula. Ayan, EBC. What is the value of E? Ito, ano ba yung E natin, guys? It is the molar absorptivity and it is always constant. And then yung B natin is the cell pant length in centimeter. Ito, ayan, nandito siya. Ay, hindi pala nakasulat dito. Sige, sulat natin. Okay, E is the molar absorptivity. Yan ay always constant, ha? Ayan. And then yung B natin is the cell path length. Cell path length. And then yung C natin, guys, is yung ating concentration of the species here. Concentration. Concentration. So, nakadepende yan dun sa may molar absorptivity natin. Kasi meron tayong micrograms per milliliter, meron tayong parts per million, meron din tayong molarity. Pero ang usually, pag hindi given yung value, ang usually units niya is moles per centimeter. This one here is centimeter. This one here is moles per liter. And then yung A naman natin is the absorbance. So it is a unitless. Ayan. So ang hinahanap natin, guys, is the concentration. And given naman yung absorbance and molar absorptivity. So let's rearrange it by isolating the concentration. So meron tayong formula E is equals to EB. So absorbance natin, substitute lang natin yung values na 0.494 molar absorptivity and the cell path length. And we will obtain A, ayan, 0.494 all over the E, which is 1.38 times 10 raised to 4 times 1.0 centimeter. So I'll drop the unit. Ito. Liter per moles centimeter. So ma-answer yung centimeter dito, ayan, we will get a moles per liter. Kasi kapag binaliktad ninyo, kapag tinaas ko siya, and you will obtain a value of input ko lang sa calculator ko to further. Ayan. So ayan, that is a 3.579 times 10 raised to negative 5 moles per liter. So ayan, ang sagot natin. Okay? So take screenshot, guys, so we can proceed on our next problem. Okay, let's proceed to our next problem here, which involves a, ayan. Okay. Chloroaniline in a sample, the chloroaniline in a sample determined as a mean pike rate. 0.0265 gram sample is reacted with a picric acid and diluted to 1 liter. The solution exhibits an absorbance of 0.368 in 1 centimeter cell. What is the percentage of chloroaniline in the sample if the molar absorptivity is 1.85 times 10 raised to 4? So ang hinahanap natin dito is the percent chloroaniline. So ang gagamitin po natin dito is dalawa. Actually, tatlong formula ang magamitin dito, pero mamaya. So we have the mass sample here. Okay, in order to calculate, we have to determine the mass of the sample, ayan, in grams, okay, times 100. And then the mass of chloroaniline. But how do we calculate for the mass of chloroaniline? Okay. Now, dito natin siya kunin. Dito sa ating Beer's law na E is equals to EBC by calculating the C or the molar concentration. Since the molar absorptivity, the cell path length, and the absorbance was measured, so let's isolate na natin yung C natin as A is equals to EB is equals to, ayan, A, okay, absorbance is 0.368 all over the molar absorptivity na 1.25 times 10 is to 4 liter per mole centimeter times the cell path length na 1 centimeter. Ayan. So, maka-cancel yan to yield a moles per liter. And we will have a value of 368. Value of 2.944 times 10 raised to negative 5 moles per liter. Pero moles per liter pa lang siya, guys. Paano natin ma-determine yung mass in terms of grams? Ngayon, gagamit tayo dito ng another formula natin. Dito papasok yung ating solution, yung molarity natin. This one here is expressed, this concentration is expressed in terms of molarity. So, we all know the molarity in our module 3. Meron tayong the mass of the solute, ayan, the general formula, all over the molecular weight of the solute multiplied the liter of solution. Okay, now we are going to determine the mass of the solute in terms of gram. Pero paano natin ma-determine yan? Okay, meron tayong molarity, meron tayong liter of solution. Sir, nasan po yung liter of solution? The liter of solution is 1 liter, so 1 na siya. Okay, and then ang missing variable value natin dito is the molecular weight of the solute. Okay, ano ba yung solute natin, guys? Ang solute natin is the chloroaniline. Sir, what is the molecular formula of our chloroaniline? Now, kung babalik tayo sa ating organic chemistry, chloroaniline has a structure like this. Suppose that ito ay nasa ortho position, kung babalikan ninyo organic chemistry ninyo. So, in order to get the molecular formula of it, ayan, no? C6H4, Cl, and H2. Ayan yung molecular formula niya. Now, in order to get the molecular weight, isasum nyo lang yung mga atomic weights niya and their corresponding multiplier based the number of the atoms in the molecule here, and you will get the value. So the molecular weight of our aniline will be, okay, hindi ko na siya isosolve isa-isa ya, kasi alam nyo naman na yung natin na yan, kung paano mag-calculate ng molecular weight. Magiging time-consuming lang tayo, guys, if i-calculate ko pa siya further, okay? Susulat pa as C. Okay, ang molecular formula, ang molecular weight ng ating chloroaniline is 127.57828 grams per mole. So, ayan. Dito natin ngayon siya ipapasok dito sa molecular weight of solute. Now, how do we determine the grams of solute? By isolating the mass of solute. So, criss-cross multiplication lang to, guys. So, the grams of the solute can be determined by multiplying the molarity, the molecular weight of the solute or the chloroaniline times the liter of solution. Okay? Now, substituting the known values, which is a 2.944 times 10 raised to negative 5 moles per liter times yung molecular weight na 127.57828 grams per mole times the 1 liter. So, ma-cancel yung liter, ma-cancel yung mole, matitira yung grams, at meron tayong grams na, okay, ayan, and meron tayong value na 3.756 times 10 raised to negative 3 grams of chloroaniline. Ngayon, itong value na ito, dito na siya papasok ngayon, guys. Wait lang. Dito nga na ngayon siya papasok. Ayan. Dito na sa may chloroaniline na ito. Okay, sir, ano po ba yung mass ng sample natin? Okay, sinabi naman dito, guys, that the mass of our sample is 0.0265. Okay, without further ado, kanina natin to. Ayan, kanina na natin, the percent of chloroaniline equals 3.756 times 10 raised to negative 3 grams all over 0.0265 grams times 100. Okay, ma-cancel yung grams. And ang value natin is 14.17. Ayan, 14.17%. Na o naman natin, kapag ni-round off natin, siya ay 14.2%. Ayan. So that's it. So take a screenshot, guys, so we can proceed in our next problem. Okay? Okay, next. Let's proceed to our sample problem number 3. Now, itong sample problem number 3 na to, guys, it is a linear regression analysis or LR analysis. Ang gagawin nyo dito is just a construction of natin. Sa may calculator ninyo, ang gagawin nyo dito is the plot the x-axis with respect to the y-axis. I-input ninyo yung calculator ninyo na yan. Ayan. So, hanggang dito mag-itsura niyan, linear regression. This one here expressed in terms of concentration or molarity. This one here is expressed in terms of absorbance. Ito mga type of plot nyo lang. Ayan. And then the unknown sample, just get the one. Ayan. Okay, so ang gagawin lang natin dito is we will skip this part kasi hindi ko siya may tuturo ng maayos about that kung paano mag-construct ng calibration curve. Pero ang kasi dapat is dapat kilala ninyo yung calculus. If parehas kayo ng calculus sa akin na FX 570 ES plus ang usually recommended, ay masasolve niyo itong problem na ito. Okay? Ang gagawin nyo lang, sige, ituro ko na rin. Gagawin nyo dito sa may part na ito is kung ano nyo yung mode, okay? Click yung mode natin, okay? Plus, press 3. Kasi ito ay stat. Ayan. And then after that, i-click ninyo yung naalagay sa may calculus o that is 2 ay a plus bx. Ano bang ibig sabihin ng a plus bx na yan? Ito ay linear equation where b is the slope and a is the y-intercept. Okay? And then, ayan, meron kayong lalabas na ganitong tab. Okay? X and y. Ngayon, ang gagawin ninyo is input ninyo mga to sa may x natin and then input nito hanggang y. Ayan, input ninyo yung mga ayan. So, ang gagawin ko dito is i-input ko siya isa-isa. Okay, this will take some time. Okay. Yan. And then after inputting the values here, ayan, suppose na na-input ko na itong mga to. After inputting the values, here, okay, plus input values. Okay, then after nun, ikuanin nyo, i-press niyo yung AC. AC. And then plus, pinutin nyo yung shift. Ayan, shift. Papakita ko naman to sa may video o sa may part 3, isisingit ko. Shift, and then, i-click niyo yung 1. Shift 1. Ayan. And then, kunin nyo yung 5. Ang naalagay kasi sa akin dito is reg or stands for regression. And then this one here is ito yung naalagay sa stat. So makita ninyo. And then you will see a series of numbers here. Okay, sa may ko na for FX 5-570 ES plus na calculator. Ayan. Yung makita kayo dito na 1A and then 2 that is B, and then 3, R, and then 4, which is X hat, and then 5, that is Y hat. Ngayon, in order to test for linearity, i-click nyo lang yung R. Dapat ang value ng R ninyo is approximately 0.999 or dapat 0.99 yan. Kapag 0.99, pasok ang values natin. Okay? Now, pero ang interest ko dito, guys, is yung equation of the linear equation. Ayan. So the B, so Y, which is the slope natin, has a value of, meron value na 743.5x. And then, yung value ng A natin, which is the Y-intercept, is 3.7 times 10 raised to negative 3. Now, the unknown sample has a concentration, has an absorbance of 0.360. Yun yung Y natin, guys. Kasi nga, di ba, pinlat natin siya with respect to absorbance equals to slope times the concentration, which is the X, and then the Y-intercept B. And then, given dito yung absorbance, we will get the concentration. So, paano ba mangyari dyan? Okay? Let's just isolate x natin. So, let's isolate x. That is y minus 3.7 times 10 raised to negative 3. Kasi kapag tinranspose siya ay negative, all over 743.5. So, what is the value of y natin? That is 0.360 minus 3.7 times 10 raised to negative 3. Ayan, all over 743.5. So, ang value niyan, guys, ay, tignan natin, 743.5 ay 4.79 times 10 raised to negative 4, which is tumama sa may answer natin. 4.79 times 10 raised to negative 4 molarity. So that's how you get a value for the unknown, the concentration of the unknown sample given its absorbance. So ganyan. So take screenshot, guys, so we can proceed on our next problem. Okay. Ayan. So let's proceed in our next problem natin na ito. Sample problem. Ayan, may mga solutions naman siya. Sample problem number 4. So ayan. So a solution containing 1 milligram of iron in 100 ml was observed to transmit 70% of the incident light. So 70% yung incident light na transmit. What is the absorbance of the solution at this wavelength? Okay. I-discuss ko lang na there we have the Beer's law again. And then yung ating po natin, we have a formula na negative log times T, which is T is yung transmittance natin, na which pwede rin natin na dito na T sub O or the incident light all over the transmitted natin in order to calculate. Itong formula na ito, guys, is nagmula dito sa may ko na ito. Ayan. The incident light and then the transmitted. So I sub O over I sub T. Or pwede ring negative log T. Okay, in order to calculate the absorbance of that sample here, gagawin lang natin is just A is equals to negative log T. So, divide mo yung 70% into 100. That is negative log times 0.70. Ayan. Ang sagot dito, guys, is 0.155 or 0.1549. And then sa letter B, what fraction of light would be transmitted by a solution of iron 4 times as concentrated? So ano kaya ang matatransmit niyang light kapag ang natin? So gagawin natin dito is the iron, ayan, ang concentration, dito ngayon papasok, guys, yung A is equals to EBC. And we will get the natin. So meron tayong A, meron tayong E, B, and C. So ang missing variable dito is yung molar absorptivity natin. But how do we calculate the molar absorptivity? The concentration of iron, ito, absorbance is given, which is ito. B is 1 centimeter. But how do we calculate for C? C, divide nyo lang yung 1 all over 100 in order to get the, ayan, the C. Kung unalin, ayan o, 100 milligram per 100 ml. Pwede rin grams per ml, pero ganun din kasi magiging result niya kapag kinan ninyo. So we have a value of 0.01 milligrams per milliliter. So let's calculate the E. So let's isolate the E, which is A all over BC. So the absorbance is 0.1549 all over the 1 centimeter times the concentration na 0.01. Ayan. So ang ating natin dito, the molar absorptivity natin is, kapag walang given na guys, na cell path length, i-assume nyo yun ay 1 cm. Okay? So the molar absorptivity is 15.49. Ayan. So letter E natin. So pero hindi yan yung hinahanap na sagot. Ano daw yung magiging yung natin transmitted light if 4 times daw yung concentration ng iron natin. So ganito lang gagawin natin, guys. A is equals to EBC. We have E, we have B, pero ano yung natin? Yung C natin. Ta-times mo sa 4 yung C natin. Okay? So magiging calculate is 15.49 times 1 centimeter, ayan, times the ko natin, ito ay 4 times 0.01 milligrams per milliliter. Ayan. Sir, saan po nanggaling yung 0.01? Ayan, no? Kasi nga sabi sa tanong is 4 times concentrated. So, 4 times concentrated, ang mangyayari dyan is pag times nyo lang yung 1549 times 4 times 0.01 and you will get the value of 0.6196. So, 0.6196 ang transmitted line. Sir, bakit po nagdirekta agad tayo dito sa natin? But pwede po bang magdirekta po pala agad tayo dito? Hindi pwede. Kasi wala tayong molar absorptivity. Saan natin nakuha yun? By using the data given above here, ayan o, we have the absorbance, the concentration, and the cell path length to get the molar absorptivity. Sir, akala po ba laging constant yan? Yes, laging constant ang ating molar absorptivity, pero ika-calculate nyo pa rin siya. Okay? So, that's the kuan natin. That's the kuan ito. So, let's take a screenshot so we can proceed on our next problem. Okay? Okay. So, ayan. Ito yung tinutukoy ko. And then this one, here's your learning activity, guys. Learning activity niyan. So, ayan. Learning activity niyo. Quiz 1. Baka lang basin sa quiz. And then, punta naman tayo sa my standard addition method. Itong standard addition method na to, covers only one problem ang solve natin. And then, pupunta tayo sa ating multi-component analysis. Multi-component analysis. But, yon ay di-discuss na lang natin sa may part 3 ng ating lecture. Kasi mahaba-habang discussion ang mangyayari dito. Okay? So, thank you for listening, guys, and see you on the part 3 of our lecture for today.